Hey, what's up, guys? Mr. Hansen, here to talk about some functions. We know that functions is a way to show how two quantities are related. So in our case, we know that functions can be anything from like how many seconds have passed since you've been traveling. We talked about that Cannon Man guy, time passed and his height changed. And when we do that, we get different information. We get order pairs, we get function notation, we get graphs, we get tables, we get tons of stuff. So for it to be a function, we know that each input has to have only one output. So if I put in your ID number, I'm only going to get your picture. If I call your phone number, I'm only going to get you on the phone. If I ask you where you were yesterday during third block, you're going to say my class because that's the place to be. You can't be in two places at once. So function notation, the f of x equals y. The f represents a bunch of stuff, but in this case, f is just the function name. Shout out to Wheezy on that one. X is your input. It's the domain value. It's what you put in. Y is the output, is what you get out. So you put this input in, you press a, the magic function machine does this thing, and out comes the output. Think about a vending machine. You press the button, you get something out. There's many different ways to represent functions, multiple representations. So the same function can have a graph, it can have a table, it can have a mapping, it could have the equation, it could have a verbal description, it could have a set of order pairs. Multiple ways to show the same thing. All right, so something a little new we're going to talk about is domain and range. You should know by now that domain is related to the x values. It's related to the input, and range is all your y values. Y is your range, your output. So this is a linear graph. It's a line segment. You can tell that because it's got points on the end. And domain is all the x values, all the possible x values for the set. So this graph exists on this little window from this point to this point. What x values are all a part of it? So I want you to take a look, and then we'll work on this. So on this one, I circled the 2 points where it ended just to give myself a little better view. I wrote domain x and drew it left to right. Domain x is your horizontal axis. So first we're gonna get our just verbal description. So what does this look like? Well, I could tell, starting on the left with the lowest value, that there's a filled in circle on the -9. So the lowest x value that this function can have is -9. Now if I look on the other side, I see an open circle, and that tells me that the highest value we could have is 2, but we can't actually have 2 because the open circle is not included. So like 1.99999 suffices. So what I know is this is going from -9 to +2. That's the verbal. So then we got to write using inequalities, and we haven't done a lot with this yet, but now's a good time to learn, so pay attention to this next part. All right, so filled in my verbal description. Lowest x value is -9. The highest domain value is 2, but 2 is not included. For the inequality, so if you don't know anything about inequality signs, it's just a way to show a range of values. So instead of an equal sign, you have multiple numbers that make the thing true. So what we're going to do is we are going to write that x, and x is any number that makes the equation true, is greater than or equal to -9. So that says every number from here over works, and then every number that's just less than, not equal to, because it's an open circle, less than 2. I wrote 2. Nope, I wrote -2, my bad. It's a +2. And less than 2. So we're going to go from -9 to 2, and that's all the x values. That's the only x values that make this equation or function true. And the next part of this is the range. Range represents all the y values. So the y values are your outputs. So we can tell the lowest y value on this graph is a -6. So -6 is the lowest value, but it also doesn't touch that because of that open circle. And the highest is +3, and it does touch that because of the closed circle. So I know my range is -6 to +3. We know the inequality version would be x is greater than -6 and less than or equal to +3, and I'll write that. So we know that the range is from -6 to +3, and inequality form is greater than -6. It's hard to read this backwards. Greater than -6, but not including -6 because it can't actually touch that, and less than or equal to 3. That's the domain and range of this line segment. So all of those x values in between can work. All right, so now these ones are pretty straightforward. It's a table and a mapping. So for domain, you're just gonna list the X values, and for the range, you're just gonna list the Y values. So I would pause the video and you can go ahead and try this for the domain and the range, and then I'm gonna do this and then you can check your answers. All right guys, so hopefully you took a few minutes, you tried to do this, you listed all the X values, the inputs for the domain, and you listed all the Y values or the outputs for the range. And this is what it should look like. I know you guys like my little curly cues, so I throw those in there for you. You could have just wrote them in a list. You don't have to use fancy notation. Those are the answers. So if you need to pause this, take a look. All I did was I took all the X's, all the domains, and put them under domain, and all the Y's, and put them on the Y's. So these are functions that are not lines. They're just a collection of points. They're discrete, not continuous. So this stuff's really important, guys, because domain and range give you options. So for example, if we're talking about total distance traveled, like the bumper car problem, that graph will start at 0 for time and start at 0 for height. So you'll never get any negative numbers because you can't travel negative time. And if you're walking, it doesn't matter what distance you're walking or driving, the distance is gonna add up. You can't have negative distance. It just don't make no sense. So think about when we're doing this math, it's not just about getting the math, it doesn't make sense. I told you guys all the time, I don't need calculators. So when I'm doing the functions, ask yourself, does this make sense? Could I see this happening in real life? And if it doesn't, you probably did something wrong. That's what I got for you. You're gonna work on the screen sheet. If you have questions about domain and range going forward, or if you wanna come up with situations and try to figure it out for yourself, I got you. See y'all later. At Mr. Hanson 414. Catch me on Twitter.